Let's look at example 5b, where we have y is equal to the square root of 2x minus 1. Now, there are really two scenarios whenever it comes to finding your domain that can be an issue, if you will. I always call them two big fat no-nos. So when you're looking at your domain, there are two big fat no-nos whenever, big no-nos. The first one is if you have a radical. Now, what's the problem with a radical? Here, this square root symbol. What can you not have underneath a square root? A negative. 0 is legit. I always have people that say 0. 0 under a square root is legit. But you cannot have a negative under the radical. So that is a tip-off. Negative under an even root. All right. Odd roots all day long. Remember, we've already talked about that. But negative under an even root cannot happen. The second thing, even though it doesn't deal with this problem, we might as well go ahead and get it taken care of. What's another big problem in math in general? What can you not have? Here's a hint. It deals with fractions. What can you not have with a fraction? That's where your 0 comes in. Good. You cannot have a 0 in the denominator. Good. Those are your two big fat no-nos. Negative under an even root, 0 in the denominator. So anytime you see a radical, that whoop, you know, your lights are flashing, something's going off saying, ooh, something's not stirring the Kool-Aid here, Ace. So you cannot have a negative underneath that radical. But the first question that we get the opportunity to ask, or answer, I guess really, is this a function? And then we're going to state our domain and range. So is this a function? Sure. Anything I put in for x can only have one output, so I can't. So if I'm looking at my x values, we're good. Nothing's going to mess with that. I'm not going to have two x values that I can put in there. They're all just singular x values. Good. Okay, let's do this then. My domain, so function, yes, check. My domain for this, okay. So if I can't have a negative under this, what's the smallest number possible to have underneath my radical? A 0, good. So I want to find the x value that's associated with the 0. So I want to know, when is 2x minus 1 greater than or equal to 0? So I want to know all of the x values that are going to be greater than or equal to a 0 underneath my radical. Good, then you just solved. So 2x, when you add 1 to both sides, is going to give you 1. So x has to be greater than or equal to 1/2. And how do you write that in interval notation? You have a bracket on the 1/2, and that goes to infinity. Good. So you want to look at the x values that are going to work, and all of the x values that are greater than or equal to 1/2 are going to make my statement true. Cool. Now look at the range. Remember, the smallest value you can have underneath the radical is what? That 0, right. So what is the square root of 0? 0. So my range is going to go from 0 to infinity. So when we're looking at these problems, you want to, a lot of times, it's whatever the smallest input is going to be associated with the smallest output. 1/2 is the smallest value I can put in for x, and that gives me, when I put in a 1/2, a 0 for your range. Cool. Now, whenever you're dealing with functions here, looking at equations, sometimes it takes a little bit for this to soak in. So feel free to go back, rewatch this video, just let this soak in and see what it is we're talking about. The kicker here are our no-nos when it comes to domain. A lot of times that helps whenever we write these. Okay, let's do a couple more. All right, let's take a look here at example 5C. Y squared equals x. Okay, so let me make that equal sign a little bit nicer here. There we are. So y squared now equals x. So if I'm looking at this problem, this is the first time that we've had a y that was squared. Sometimes I think it's easiest to do a t-chart. And because the y is squared in this instance, typically we always look at the domain first and the x values first, but because the y is squared, let's look at that. So give me a value for y. How about 2? Okay, so if I plug that in, what is 2 squared? 4. Awesome. Okay, now what if I say y is negative 2? So I have a negative 2 squared. What's a negative 2 squared? That's also 4. What? So if I'm looking at this, what just happened? If you end up with an even power for the y, so then you can either have a positive or a negative, that's going to give you a repeating x. Is that a function? Heck no, it is not. Cool. So basically what we're looking for here, and to determine just looking at an equation, so just look at the equation, and if y is to an even power, not a function. That's it. If you look at an equation, if y is to an even power, then it is not a function. Good. Everything else, legit. And typically you have just a plain y equals something. You know that's always going to be a function. Good. Good for you. Let's try another one. Oops, hang on there. I almost jumped the gun. We have to do a domain and a range for this thing. So let's take a look, because even if it's not a function, we can still have a domain and a range, right? Now let's think about this. What kind of values, and again, I'm going to start with my range because this y is squared. So what can I put in? Remember, we have two big fat no-nos when we're looking at our input values. Cannot have a negative under an even root, and cannot have a 0 in the denominator. Do either one of those situations apply? Nope, I agree. So, because of that, with your range value, you want to look at the y values you can plug in, and it can be anything. So that's going to take us from negative infinity to positive infinity. Good. Now let's look at the domain. Think about this for a minute. What happened up here whenever I plugged in a negative 2 or a positive 2? What happened to the x? Yeah, it was positive, right? Is there any possible way for me to get a negative x value out of this deal? No siree. So because of that, my domain is going to go from 0 to infinity. Good. Good. Cool. Okay, now let's try another one. Okay, check this out. Y is equal to 5 over an x minus 1. Now, remember we have those two big fat no-nos. However, if I can determine whether or not this is a function, is it a function? Yes. And what tells me that this is a function? Just this y. Is the y to an even power? Nope. So it doesn't matter if it's a fraction, a radical, whatever it is. The only thing you're concerned about whether or not it's a function is the y. So because y is not to an even power, yes, this is a function. Okay. So now let's hang out with our domain and our range a little bit. Now remember the two big fat no-nos when it comes to domain? You cannot have a negative under a radical or a 0 in the denominator. So what value, if I have x minus 1, I want to know what value is not going to work, and that is 1. every other value out there works except 1. So if the only thing you can't have is a 1, how do you write that in interval notation? With a union, good. So you basically we're just going to jump over 1. So I'm going to go from negative infinity up to 1, jump over 1 with the parentheses, and then pick it back up and go from 1 to infinity. So up to 1, but not including, that's why we have a parenthesis, and then from 1 again on to infinity. Because you can have 0.99999, that all works, and you can have 1.00001. I mean, anything super close to 1 works, just 1 is the only thing that doesn't work. Now let's think about the range here. It's a little bit tricky. The range, we can have pretty much everything except there's one value again that's not going to happen. And the only reason for that is because I have a 5 in the numerator here. Because I have a 5 in the numerator, there's no way I'm ever going to get a 0. Because the only way to get 0 is 0 divided by some number. So because of that, I'm going to go from negative infinity up to 0, union with 0 to infinity. Cool. Cool. A lot of times when we're doing these problems, we're really looking for the domain. Your homework asks you to put both the domain and the range, which is what we're doing. But a lot of times, especially when we're talking about functions, we want to know, okay, if the x's can't repeat, what value of x's are really going to work? So typically we focus on the domain. But it's always nice to know the output, what you get out of the deal here with this range. Good. Nice job.